Yes, ma'am, visible, ma'am.
Yeah. So today we will see the constitutive matrix for the plane stress problem. Already we have seen something, and if you know this one only, then you will be able to find out beta transpose. That is beta transpose integral of beta transpose dB. dB. If you take the bar element D is equal to E. But for plane stress problem, the D will be something else. So we have to formulate the value of find out the value of D. The D is called the constitutive matrix. If you want, you write K is equal to, for finding out this, we need the constitutive stiffness matrix. K is the stiffness matrix. If you want, you can note it down. Stiffness matrix. And D is the constitutive matrix. Take some of that. Constitutive matrix. So we are going to derive this constitutive matrix for the plane stress problem, and if time permits, we'll do it for the plane strain problem also. Then only we can complete the yesterday's problem. That is, yesterday we have seen the how to formulate the beta matrix, how to formulate the beta matrix for the constant strain problem. So you have to just note it down. So constitutive matrix. Constitutive matrix for the plane stress problem. So we learned already epsilon x, that is dou ux by dou x, and epsilon y dou uy by dou y, and epsilon xy is equal to dou ux by dou y plus dou uy by dou x. This with respect to u of x is the displacement function. U of x and u of y are the displacement function. So I can keep this epsilon x is equal to dou by dou x 0 0 dou by dou y, then dou by dou x of, I'm taking the common values of u of x and u of y. So now you do like this. When you multiply dou u of x, dou u of y, then this is dou u of x plus dou u of y. So you'll be getting this values. So for the plane stress problem, we have sigma x, sigma y, and sigma xy. Sigma x for the plane stress problem. So we'll formulate for the plane stress problem, then we'll move on to the plane strain problem. For plane stress problem, we have sigma x, sigma y, and sigma xy. So already we have learned epsilon x is equal to sigma x by E minus mu into sigma y by E. That's the Poisson's ratio. And similarly, epsilon y is equal to sigma y by E minus mu into sigma x by E. Similarly, gamma xy, sorry, epsilon xy, that's the shear stress. These are the normal strains, and this is the shear strain. This is, if you want, you can mark it up. This is the normal strain, normal. So we learned about two quantity, no, normal strain and the shear strain. This is the shear strain. Class afternoon. Sigma epsilon xy is equal to sigma xy divided by g, that is equal to 2 into 1 plus mu divided by E. So this and all we have learned already. Now what you have to do is you take that sigma x, and we are going to find out sigma x and sigma y value from this. So if we take sigma x and sigma y, this is, let us take, this is equation 1, this is equation number 2. Can you find out the value of sigma x and sigma y from this? Find out the value of sigma x and sigma y. What do you have to do? Can you find it out? Either you do it as a the simultaneous equations, you take it and you do it. Try this one. I'll give the final answer. Check whether you are getting the same answer. Tell me the value of sigma x and sigma y. Excuse me. Are you getting this value? So I can take it as E by so from this I have found out the value of the equation 1 and 2. This is equation number 3. So equation number 3, from the equation number 3 you can get the shear strain. So how will you solve these two equations? You can make it, that is if you multiply by this one with the gamma, then this terms will go off. So you will get these two terms remaining. Like that we have done one problem now in the class. How to solve the two simultaneous equations. Same way you have to solve it. When you simplify that, you will be getting sigma x and sigma y value like this. So I can write, this is in terms of epsilon x and epsilon y. If I want to add the shear, shear strain also, I can write like this: sigma y sigma xy. Minus mu square 1 0 0 0 1 minus gamma divided by 1 plus r square. Sorry, 1 minus gamma. 1 minute. Gamma by 2. Whether you are getting this. So this is called the constitutive matrix. So this is called. So let us take this portion as D. So D is nothing but the constitutive matrix. Constitutive. So this is the constitutive matrix. So E by 1 minus gamma square 1 gamma gamma 1 0 0 1 minus gamma by 2 is the constitutive matrix for the plane stress element. Just check it. I'll give you time whether you are able to get the same answer, because I have skipped some of the steps. That is, I didn't tell you how to solve these equations 1 and 2. From the equation 1 and 2 only, I have found out the value of 1 and 2 only. I have found out the value of sigma x and sigma y. Sorry, sigma x and sigma y I found out from equation 1 and 2. Then finally, I added the sigma xy value. That's the shear stress. Sigma xy is the shear stress and sigma epsilon xy is the shear strain. So these two are the normal strain. So already we have learned now what's the meaning of normal strain. If you want, I'll just move on. And these are the strain. That is normal strain and the shear strain. Normal strain and the shear strain we have learned. And so plane stress problem. Check it whether you are having these values. I'll give you time, because I didn't solve this equation 1 and 2. Just check whether you are able to get the answer like this. So this is called the constitutive matrix for the plane stress problem. So tomorrow all of you should write a test in the derivation of a that is shape function for the constant strain triangle element. That's so tomorrow's test, because every week you have to write something, and tomorrow you have to take a test on a derivation of constant strain triangle element. Check it. Anybody is getting this answer or not? Tell me. So this is sigma x and sigma y. Finally, I added the sigma xy value. So from this equation, suppose if these two equations, I can find out the value of sigma x and sigma y. This is a simultaneous equation. Anybody has done it? Sweda, have you found out? Yeah.
The equation from
Yeah. Solve it. It is voice breaking. Your voice is breaking. Did you solve this?
Equation format.
This equations you solved. You were able to solve and get the answer.
Yeah.
Only I have given the answer.
E by 1 minus.
1 minus mu square 1 mu 1. Are you getting this answer?
Matrix. Putting nu into epsilon x plus epsilon y, ma'am.
Epsilon? Epsilon x and epsilon y. So if you are getting this this value, and then the sigma xy, just addition of the shear strain. Shear strain, same thing only. You have to, but I have taken 1 minus nu square commonly outside, so I have to make some arrangements here. So that's the thing I have to do, because epsilon x is epsilon xy is equal to 2 into 1 minus nu divided by e into 6y. This is a g value, the value of g. You got the values? Jagan, what about Jagan? Jagan, have you got the value? Jagan? Hello? Were you able to solve these two equations, Jagan? Hello, can you please unmute your mic? Thamari Selvan,
Yes, ma'am.
you were able to get the answer? You were
Yes.
able to solve it?
Yes, ma'am.
Okay. Okay, time over. So we will do it. Uh, the plane strain problem, that is this is a plane stress problem, constitutive matrix. Did you put the title like that? This is a constitutive matrix for the uh, for the plane stress problem, for the similarly we will be deriving the constitutive matrix for the plane strain problem. This is for plane stress problem, and we'll see in the next class what's the difference between the plane stress problem and the plane strain problem. Here in the plane stress problem, what is the difference? Already we have seen when the continuum is very thin, then it is enough if you analyze as a plane stress problem. If the continuum is very thick, then you have to go for as a plane strain problem. So that's the difference. So this one we have seen the last class, and finished. So we will see the derivation of the plane stress problem, the strain problem, constitutive matrix in the subsequent class. So tomorrow, till your class, Ms. Smita, can you inform all the people that they have to take a test on the derivation of the constant strain triangular problem tomorrow? Okay, can you inform them?
Yes, ma'am.
What about Mikias? Why didn't you come today?
Don't know, ma'am. I'll inform them, ma'am.
Okay, inform Ergebe and Mikias also. You have to upload assignment. Okay, not assignment. It's for assessment, and you have to open your video. When you are writing the test, you have to open the video. Video should be in the on mode, and you have to write. Okay, thank you very much. Thank you. We'll see you tomorrow.
Thank you, ma'am.